right, good to be back here. So as the CEO of EngFlow, it makes me happy to bring more Bazel engineers on stage who haven't given talks yet. And so this time I'm joined by two awesome engineers, Gabriel Russo from Databricks and Yuval Kaplan from EngFlow. EngFlow powers world's most complex and critical software with remote execution and caching, observability, and Bazel knowledge. Companies who onboarded into EngFlow have achieved significant performance and reliability, as well as the cloud cost savings over other options. I talk about how we achieve significant cost savings and performance savings in my sponsor talk at BazelCon 2024. But our Databricks story actually didn't start this way. So this talk is a journey into how we work with our customers, how we give them the value of improved cost, performance, and reliability, and how we use the strength of both companies, scale and data, to optimize performance, cost, and create a great environment. So Databricks runs the largest RBE deployment outside of Google. If anyone here wants to contest that, speak with me after the talk.
All right. So yeah, I'm Gabriel. I work at Databricks. Just to give a little bit about, talk about the scale that we operate on. We have almost 3,000 engineers now. I run a simple line count in our repo, and that gave up almost 100 million lines. Not all of them are human written, but Bazel doesn't care. He has to build all of it anyway. Our code is growing quite a lot. That's the first graph on the top. You can see the very exponential growth of Scala lines, and those are 100% human written. We are a big Scala shop. We also have a lot of JSONet, which is this, or JSONet, I think, which is this configuration language, Rust, Go, Java. Python is growing a lot with all the AI rush. And the bottom graph, you can see the number of actions we are running per day during our builds. We did cross the 2 billion mark at some point as a mistake, but we are about at the 1 billion mark now. And I'm just going to give a quick overview of how our CI works before. So a developer submits a change. We have some fancy models that are running, so we run Bazel queries, we feed that into some machine learned models, we run that against some databases to check against known failures and things like that. That spits out a list of targets that we cannot run in a single machine, so we would actually run Bazel tests in many machines. But that has plenty of problems because we are building the same thing over and over. We are cloning the repo over and over. And even inside those machines, we have noisy neighbor issues. And to combat the noisy neighbors, we actually tried to, we actually successfully contributed to Bazel upstream by introducing C-group-based resource isolation on Linux. So you can actually have CPU or memory-based resource isolation today. I think it landed in Bazel 6 or 7. I don't recall. The problem with this, I think there was a talk from Glean earlier today that if you just try to vertically scale, we try to horizontally scale it in a simple way. The cost just grows and the problems keep coming. So if we said, okay, we really need remote execution now. So that's what we did. We partnered with EngFlow to have remote execution, and we migrated one of our most important CI jobs, which runs the test for Spark. And this graph is a Databricks query, but the blue line shows the runtime, the P90 runtime that developers would have to wait for their CI with remote execution, and the bottom one without. And that's not what we want, right? We want remote execution to make things faster and not slower. So the thing is, at Databricks, we are really good with data processing. So we were actually already ingesting a bunch of Bazel data. For every single Bazel build, we were ingesting all of that data from BEPs and trace files that were also mentioned earlier today. And we can run very simple SQL queries or human Bazel queries, because it's very hard to read those BEP files and whatnot. So we have all of those in tables that we can just query. Even now with AI fancy things, we can just write plain English and it spits out what's going on. And we did the investigation, so we ran a bunch of queries, and then we realized that these targets under //Python were much, much slower in RBE compared to not RBE. And this is the blue line is basically those tests in RBE. So we were like, okay, why that is the case? And it turns out that these targets, they run in Docker, so they are integration tests. that require very large Docker images, and they were much slower in remote execution. And because they have a runtime of more than 10 minutes, that's a really significant amount of time for the overall CI job. So I'm going to hand over to Yuval that can explain why those were so much slower and how we made them faster.
Hi. So we drilled down, and the metrics told us that integration tests are quite a bit slower in remote execution. And we know that these are pretty IO-heavy tests. So it's pretty logical, right? We should try faster disks. The original setup that Databricks had used SSDs, and we used EBS. We usually use EBS on machines that don't have local disk, simply because it's a good balance between cost and performance. But in this case, it was clearly not enough. So we switched to SSDs, and we saw some improvement. We saw some performance gain, but now we're running into another problem. We found that we needed really, really large disks for these actions. So here's why. Those tests are running with, they're using Bazel-built Docker images. We build these images using Bazel, and then they get passed on to the action as inputs and loaded into a Docker daemon. Now, this isn't the host machine's Docker daemon. For hermeticity and security, this is the Docker daemon running inside the execution container. And when you have a worker machine that has multiple executors, you end up having n+1 copies. You have one for the input and one for each executor. So when you have ephemeral disks, larger disks mean larger machine types, and these are more expensive by far. So we want to cut back the cost while maintaining the performance. So can we do that? And it turns out that we can. Docker, actually, containerd is pretty modular. And the piece here that's in charge of where the layers are is called a snapshotter. So there's the default snapshotter, which just takes layers and uses overlayfs to provision the file system for a container. There are some fancy snapshotters that implement lazy loading to optimize the loading of large Docker images. And in this case, we needed a snapshotter to fine-tune where we put the images, the layers, actually, so we could share them among all the inner Docker daemons. Now, we could do more than that. We could, for example, decide to keep some of the snapshots on fast storage, for example, scratch layers, and read-only layers on slower storage. But we just didn't need to do that because everything now fit on smaller SSDs. And so we achieved the deduplication that we wanted, and we could cut back to using smaller instance types. And besides reducing disk usage, we also saw a pretty significant reduction in test runtime and variance, which you can see in this graph. Now, just to close the loop, we asked ourselves, do we actually need those SSDs, or is the snapshotter good enough with EBS? And it turns out that there's still a small benefit to using SSDs. It's not quite as big, but for this specific setup, SSDs were already cheaper, so cheaper and faster, no need to choose.
Yeah, so we don't have time to talk about other optimizations that we've done, but we also were able to ingest all of the RBE server-side data into Databricks, so we can also run SQL queries on those things. And this particular graph shows the overall time it takes for an action to running RBE, the blue line, so the top line, and the bottom line shows the time that the action actually ran, so without uploading inputs and downloading inputs and starting containers and all of that. And we can see that over time we were actually able to basically eliminate that overhead on the P90 level, which significantly improves the overall CI times that our developers have to face. So this was really cool. I think this graph is really cool, that the overhead basically goes away, and we can see that really easily with Databricks.
So what we live for, to see our customers this excited about their developer environment. So we are an extension of your developer experience team at EngFlow. So we carry the pager for the clusters. We monitor proactively, specifically across 3 parameters: cost, performance, and reliability. And we alert you and make continuous improvements there. Also inspired by this partnership with Databricks and seeing what they've done with the Bazel data, we've also incorporated some of our learnings and implemented that as part of our platform. And so this week we're talking a lot, and you can see about this product. It's called Build Forensics. That's essentially an extension to our build and test UI that allows you to run queries flexibly in the analytical environment. It's a playground sandbox that you can inspect your builds, but also it's an environment, it's a package that you can import into your own analytical data store, because we notice many of our enterprise customers actually have quite large analytics environments as well. And so if you stop by the EngFlow booth today, you'll play the analytics game that I talked about earlier, and also we'll send you Cluzel, which is our custom Bazel analytics game, board game actually. And you can also play this game tonight at our happy hour, along with other games, food, drinks, and good company. Thank you.